Hello guys, my name is Devin, my YouTube channel is DRG Bros, and welcome today to another video. This one is going to be on integration by parts, as you've most likely read from the title, but I'll just say it anyway. So, integration by parts is basically when you have an integral, but it is not possible to do a u substitution, okay? So, I have 5 different problems that I want to show you guys today. This one's going to be a little different than the videos we've done in the past. So in the past, I'll be like, okay, here's the topic, here's how to do it, here's an example problem. But in this video, I have 5 example problems, and I'm going to show you the example problems and explain along the way how to solve the problem. And I hope by problem number 3 at least, you understand the base of what we're doing. However, the calculation does get a little, yeah. So, the first problem that I wanted to show you guys is the integral of x e to the x dx, okay? So now, yeah, as I said, this is not possible to do a u substitution. You can't do these. So the first thing you're going to want to do is we're going to use this formula throughout the video, and you're going to use this every time you do integration by parts. uv minus the integral of v du. That probably makes no sense to you. But, yeah, I've gone ahead a step just to show you why we have these. We're going to create almost like a mini table over here. And we're going to use 4 values, u, v, du, and dv. You'll notice I've only written down u and dv right now. You'll see why in a minute. So we're gonna u can either be this or this, okay? This or this. U kind of splits it, and dv is the other part. So in this problem, we're gonna want u to be x. See? U is x, which means dv is what's left over, e to the x dx. Okay? So now we're going to differentiate u, and I forgot what the word is, but we're going to basically undifferentiate v. Okay? I forgot what the word is, I'm sorry, but yeah, so it's going to be du equals dx. Okay? Now, technically, I have skipped a step here. You're going to want to divide by dx, I think. But this is kind of just a shortcut in this case. So it's okay. I skipped a step, I know, but it still works. And then v, we can get rid of the d's, so v is e to the x. Think of it as we're adding a d. Think of it that way. Okay? So now, you see why we have these values. So now we can plug them in. So that's x e to the x minus the integral of e to the x dx. Then we're going to integrate this, I think is the word. So it's going to be x e to the x minus e to the x plus c1. So we differentiated the dx, so it's minus e to the x, and we have this. This, right here, this is called the integration constant. And that's basically what happens to the integral. It kind of becomes that. So, if you don't understand this, I highly suggest you rewind the video and take a look at it again. Because, yeah, it does get more complicated, so I want to make sure you guys understand the basics before I go too far. So, if you're not sure what's happening, please rewatch this video. And then when you get back here, if you understand it, just move on. Okay then. So, the next problem we're going to do is pretty much the same thing, except we're going to throw in the sine and the cosine. So it's going to be the integral of x cosine of x dx. Okay? So we're going to do the table first, because that's normally what you're supposed to do. So u equals x, and dv equals the cosine of x dx. Okay? X and cosine of x dx. See how I split it? X and cosine of x dx? I should probably make that a dashed line. And then differentiating du equals dx, and undifferentiating, that's what I'm just going to call it, is the sine of x. Okay? Because the sine of x becomes the cosine of x. If you're not sure if you got v right, differentiate v. Because we know that because of the cycle, the sine goes to the cosine, which goes to minus sine, which goes to the minus cosine, which goes back to the sine. Okay? So, remember this. That's a pretty easy way to figure it out. It's pretty much an endless loop. So if you're not sure if you got v right, see if it follows this loop. Does whatever it is come before the other one? So in this case, sine of x, there's a sine of x, or there's a sine. Does it come before the cosine? Yes, it does. So we know that v is right. That's just an easy way to do it. So that's uv. We're going to just write this in every single time. You don't have to if you're writing this out with me, but I'm going to. It's just easier to remember. So uv minus the integral of v du, plug in the values. So it's going to be x sine of x minus the integral of the sine of x dx. Okay? Now we're going to integrate the last part again. We're going to do this in every single problem. So it's going to be equal to the x sine of x. Okay, I think that's a minus sign. My notes are a little unclear because I have an equal sign there, but I think it's supposed to be a minus. Minus the minus cosine of x, make sure to put this in parentheses, plus the integration constant. Which, this could be the solution, but we have two negatives, so we can simplify it a step more by just adding the negatives to get a positive, like so. Same thing, just a plus instead of two minuses. There you go, first two problems out of the way. So that's really the basics. Now we're going to move on to some other problems, and keep in mind, these are easy problems. The hard ones are not nearly as easy. So just be ready for that if you're going to see this, okay? Also, the last two problems that I'm going to do are pretty good questions to be put on tests. So if you see this and you're in like high school or whatever, having this for a test, or college or whatever, keep in mind that these could be on there. So just, these are pretty famous problems. They're just, yeah. So now we have okay, sorry about that. My video cut out. I don't know why. I think I hit like enter on my keyboard or something. Sorry. So number 3 is going to be the integral of x squared e to the x dx. That's our problem. So u is going to be x squared. Again, do you see how we're going to split it? And dv equals e to the x dx. Okay? Du is 2x. Keep in mind the 2 comes in front. 2x dx. And v is e to the x. Okay? Do you understand all those values? Because again, if you don't, you might want to go and review this. I have this in one of my other videos, I'm pretty sure. So, yeah. Just, yeah. So then next, we have, again, our thing, uv minus the integral of v du. And now we're going to sub the values in. So, x squared, e to the x, minus the integral of e to the x 2x dx, which we can simplify to x squared e to the x minus 2, the integral, x e to the x dx. Now, does this step look familiar to you? Well, it should, because, if you look back, just a second, I have to separate my work from my notes, but if you look back at what we did, that's pretty much the same thing as the first problem. So I'll write it again for you out on this page. X e to the x minus the integral of e to the x dx. Isn't that pretty much the same thing, just without the squared and the 2? Because it pretty much is. So we can solve it in kind of the same way, because there's 2 ways to do this. We can either reuse substitute the right side, or we can continue solving. And we're going to have to reuse substitute, or sorry, not use substitute, integration by parts. Sorry, I get the 2 mixed up a bit. In the last problem, so you will see that. So then that's going to be x squared e to the x minus 2 parentheses, sorry, bracket, not parentheses, bracket, the integration of. So x e to the x minus e to the x plus the integration in bracket, which then we can spread out to x squared e to the x minus 2x e to the x plus 2 e to the x plus c1. That's your answer. Okay? And I know there's a lot of x's in this problem, so just stick with me here, okay? Now the next one looks easy, and that's because it is kind of easy. You just got to know what you're doing. So it's going to be the integral of the natural log. You're going to write that as a cursive ln, x dx. Not too hard, right? So u is the natural log, as you probably would have guessed. And dv is dx. Now, as you would have probably expected as well. So I'm going to do v first. So v is just going to be x, okay? Because differentiating dx is 1 and 1 is x in this case. Now, the other way, du, the natural log we can actually rewrite as 1 over x dx. Pretty cool. So, again, we're going to write our thing, uv minus the integral of v du. Sorry, just a second. And that's going to be equal to minus, every time there's going to be a natural log, you're going to put it in parentheses. The natural log of x, sorry, the x goes in there too. I closed my parentheses too quickly. X minus the integral of x, parentheses, 1 over x dx, and parentheses. Okay? And then we can integrate that, and that's x, the natural log of x minus x plus the integration. And that's number 4, okay? Now, just forewarning you, this last one is a bit of a long problem. So, be forewarned, okay? This is pretty much going to take up the whole page. So, just be ready for that. As I said earlier on, I think it was in problem 3, that we're going to have to W substitute, and we will. So, I'll explain that when I get there. So the problem is the integral of e to the x sine of x dx. Doesn't really look too hard, but trust me, it's a long one. So that's going to be u. So u is going to be e to the x. dv is the sine of x dx. I'm assuming you know where those values come from, if you're still at this point. v equals minus the cosine of x. Remember what I did with the graph earlier. The cosine of x is in front of the sine of x, so it is. And if you don't trust me, draw one out for yourself. It works. Go back and draw it out. And then du is going to be e to the x dx. It's pretty normal. We're going to write our thing, uv minus the integral of v du. And then we're going to plug it in. So it's going to be e to the x, parentheses, minus the cosine of x, minus the integral, parentheses, minus cosine of x, and parentheses, e to the x dx. Like that. So that's equal to minus e to the x. I know this doesn't look like a minus sign, I'm sorry. Cosine of x plus the integral of e to the x cosine of x dx. Basically what we did is we took this negative, and this negative, and we kind of just moved it around a little bit. So here we go with the next u substitution. So now here's where the next one's going to be. So u is, imagine this as a brand new problem. Okay? So u is going to be e to the x, and dv is the cosine of x dx. Okay? See, again, because we have the thing out split. V is going to be the sine of x, and du is going to be e to the x dx. So then it's going to be minus e to the x cosine of x plus, in brackets, our formula uv minus the integral of v du. And then we're just going to plug everything in, as we did before. So minus e to the x cosine of x plus e to the x sine of x minus the integral. Oh, and this is still in brackets. Sorry. Sine of x, e to the x dx, and bracket. Okay? We're almost done here. Only about 3 more steps. Then it's going to be minus e to the x cosine of x plus e to the x sine of x, no more brackets by the way, minus the integral of e to the x sine of x dx, which is equal, the equal sign's not here actually. The integral of e to the x sine of x dx is equal to, now the equal sign, minus e to the x cosine of x plus e to the x sine of x, see, minus the integral of e to the x sine of x dx. Okay? One more step now. Notice that we have 2 integral e to the x sine of x dx's. So we can put those together. So it's going to be 2 integral of e to the x sine of x dx equals minus e to the x cosine of x plus e to the x sine of x. And you might say, well, Devin, one's positive and one's negative. How come it's just not 0? Because when we transfer this to the other side, when we pass the equal signs, the signs flip. So now it's positive. That's why. Technically, you could have written this out if you wanted to do the extra step as the integral of e to the x sine of x dx plus the integral of e to the x sine of x dx is equal to, but it's just easier to just do this. Right, so the final step for our solution is we're going to take this and we are going to divide each side by 2. So it's going to be the integral of e to the x sine of x dx, which, again, if you'll notice, is actually our starting problem. This is how we're solving this one a little differently. Is equal to 1/2 bracket of minus e to the x cosine of x plus e to the x sine of x. And that is our final solution. So thank you guys very much for watching this video. I hope you enjoyed, and there will probably be another video out soon on u substitution. So stick around for that. Bye guys.